So, do you believe we are the only intelligent life in the universe?
All right, so...
It's on.
Do you believe in aliens?
Yeah. Okay. I've actually given this a lot of thought recently. And the conclusion that I've come to, and talking to a lot of people about this, is that it does look like that we are the only intelligent species, at least in our galaxy, if not nearby. And I'll quantify what I mean by that. So,
that sucks.
so the universe.
Other galaxies, bro.
Yeah. The universe is 14 billion years old, right? The Earth is 4.5 billion years old. Life on Earth, 3.5 billion years, etc. But stars that could host planets that could have life have been around for a long time before our sun was born. So if intelligent life was easy, you'd expect there to be intelligent life in the universe, which is many millions of times, if not billions of times older than our life here, right? Now, what's going to happen with that life? Well, you could imagine that it just sits on its planet, but it doesn't sound about right.
No.
Curiosity. Curiosity, and the fact that you need more energy, right?
Yes.
Right? So you start to harness the energy of your star, right? We would notice that. If a civilization arose that could harvest the energy of stars, right? What they would do is that they would take the starlight and it would be reprocessed into infrared. And if they could do that in one star, then they could get to the next star and do it there. So essentially, if you have intelligent life that starts to explore and starts to use the energy of entire stars, then very quickly they take over a lot of stars and they start reprocessing that starlight into infrared and lower radiation. But we see starlight.
Well, let me say this though.
But that's life as we know it.
So how many?
Sorry about just to tackle this. What you're saying is that the life as we don't know it doesn't use energy.
Doesn't harness the energy of stars for their own intergalactic travel.
But it's the most obvious energy source around, isn't it?
As we know.
So to my point, so how many species since single-celled organisms has lived on planet Earth?
Oh,
a zillion, right? A zillion. Okay, so just a crazy large number. As far as we're able to, understand, we're probably the only one species that's been able to think about or say, or theorize about harnessing the power of a star. And I mean intelligent as in us sitting here speaking, travelling the cosmos, whatever.
Consciousness.
Yeah. So, all right. So are you saying that there may be, say for example, dinosaurs, right? Say dinosaurs, or chimpanzees or an alligator or whatever. They're not going to be, travelling through space. They're not going to be harnessing the power of stars, going into other galaxies and reaching out to us, sending radio waves, whatever. But they're alive. So living...
Well, you said intelligent life.
I know I did, but it depends on what you call intelligence again.
Okay,
sure.
sure.
Is an intelligence a sentient being that goes and lives in families and whatever?
Okay.
So it's kind of, again, what are you defining?
Sure, yeah.
But my definition was kind of like outside of like single-celled organisms and sludge.
Yeah.
Is there anything... Yeah. Do you still believe that would be the case? That there'd be no dinosaurs kicking around anywhere? Dinosaur aliens?
So let's think about what we're saying here, right? I think that life possibly as pond scum might be common throughout the universe, single-celled, very simple organisms. Now imagine that complex organisms are common, right? So you can play the numbers game, right? How many potential planets there are, right? So you'd have all of these potential planets. And what we're saying is that there's complex life everywhere, but only on this one planet were the conditions right for one of the creatures to start thinking in a slightly different way.
Yep.
And it didn't happen on any of the other planets, thousands, millions, billions of other planets, right? It only takes a couple of them to become intelligent 1 billion years ago and to move off their planet to rapidly colonizing the galaxy, right? So what we're saying is that what we would like is that the evolution of complex life is easy, but then that step to intelligence is somehow how hard.
Yes.
Right? But in fact, it seems that part is the hard part.
Yeah, exactly. The step is a lot easier for the next part.
Yeah. Well, why is no one else taking that step? Look, the thing is...
Why would they assume that we're intelligent life then? Like, why would they want to reach out to us? That's assuming that we're like the fact that we don't know the fact that you believe there's no other life out there,
intelligent
life makes me believe that they would think that. Like, why would they try to bother contacting us?
Well, no, I'm not talking about contact.
Might be the most. We may or may not be. We may be the. If there are other intelligent life forms, we may be the smartest life form in the universe.
Yeah, but we could be the dumbest.
Yeah, that's right. That's right. Yeah. We don't know. So, but my thing is to the intelligent life theory. So, again, going back on the planet Earth, so 4 billion years, right? And we've had all these organisms, all these species, all the way up to us right now. So, how long we had radio waves?
Since like the 1930s or something, isn't it?
100 years nearly, right?
Yeah.
So if you work out, and I'm not good, like I need a calculator, but if you go 4 billion years divided by 100, so it's going to be 0.000 whatever. That's how long we've had complex organisms for however long, whatever.
Yep.
But that's the space of time that we've been able to send out radio waves, or to go to the moon, or to think about going to Mars. So, but we've had humans that can communicate for a long time before they had radio waves. So
okay. Can I to pull things slightly to the side, because
get in there, brother.
People
certainly can, Geraint, Louis.
People mess up a few things here, right? So you're
not telling me that I messed up, eh? Okay.
So you're talking about radio waves and you're talking about communication, right? Mm-hmm. So archaeologists, right? When they go off tromping around, what do they tend to find?
Bones,
but
rocks. Dust. No, they're geologists.
Yeah.
Sand. Yeah.
Nothing.
What's the answer?
So you find rubbish.
Yeah.
Okay? Humans have produced rubbish from the time we lived in caves. We've produced pollution. Okay? We have produced waste, and we've produced waste heat. Okay? So one of the natural things is that you produce waste. Now, if you've got a civilization in a galaxy, right, they produce waste. And I don't mean there's bits of plastic, etc., but one of the key things is that any civilization that occupies a large volume and is using energy equivalent to the energy of stars reprocesses that energy from starlight to infrared, right? Because that's what you do. You must produce waste, okay? We don't see the signature of infrared waste from civilizations. We see starlight. People are not harvesting starlight. They're not producing waste that would be obvious. So it's not a question of contact. It's the fact is that like the archaeologists that find the guys in New Zealand, when they find the bones of moas that have been there, you know what's been going on. You know that there was people there before. When we look out into the universe, we don't see evidence of this waste heat product that would be produced by a civilization and a big civilization would have to harness a huge amount of energy. And that's the signature that's missing. So it's not the fact that we're looking for their I Love Lucy.
Yes.
Right? It's that we don't see the waste they produce.
Yeah, and just so I'm understanding what you're saying. So, say for example, you took humans out of the equation on Earth, and you just had every other living organism. Would they produce the same waste product that you would see if you're looking at the elements on Earth from a telescope from another planet?
You could work out that there's life on Earth because the atmosphere is a non-equilibrium, right?
Yep.
We should have a carbon dioxide atmosphere like Mars or Venus. We're non-equilibrium because there's life going on Earth. You could work out you could see the waste. The sunlight is being reprocessed into infrared, right? But it's actually, because the way trees work, it's actually capturing. Trees capture that energy, right? Which is then released when the trees are burnt or break down, etc.
Yeah.
So we can see that there's that processing going on. But it would be even more extreme if you were trying to develop a method to capture lots of starlight. I mean, you think about it. Right? A solar panel collects sunlight, runs your refrigerator, which makes infrared.
Yeah.
I mean, essentially, that's what you would do on a giant scale.
Yeah, that makes sense.
And we don't see that. And the startling thing is that if you have a civilization that can travel from one star to another, and it doesn't have to travel at really high speeds, just chugging along, take a few thousand years to get to each star, right? Establish itself and then move on to the next star, harness the energy, move on to the next star. You would colonize an entire galaxy in 10 million years.
Yeah.
And 10 million years is nothing.
Yeah,
right?
on the cosmic scale. Yeah.
So if in the last few billion years there was a intelligent life in our galaxy that could do this, they would have done it. This is the Fermi paradox, right?
Yeah.
So
can I just ask a question then? Because that's just opened me up to my mind's been blown. There's that age-old thing of the fact that then, millions of civilizations could have intelligent life could have existed billions of years ago, or that they have occurred over 10 billion times if you look at the sheer rate of possibility out there. But isn't it so for our solar system and then our galaxy, the conditions for even single-celled organisms to exist have only come to fruition in the past couple of million years, or hundreds of million. For life to occur,
billion years.
So we've had life on Earth for about 3.5 billion years.
3.5 billion years. Okay, so the conditions of our galaxy or our solar system have only allowed for life to occur within the last 3 billion years.
Yes.
Okay.
But it's remember what happened is the Earth was hot.
Yes.
And it cooled down so that you could get liquid water. And that took a while.
Yep.
And it was very rapidly after that we got our first life on Earth.
Yes. Does that remain constant for the rest of the universe? Or is it just our Earth?
Nobody knows.
Nobody knows.
Nobody knows.
So then it could just be the fact that there are millions and millions of humans out there that each can't connect to each other. Like, can we see that far?
But one thing I can tell you is that if there are other Earths out there, they're not going to be the same age as this planet. They could be 1 billion years older or 1 billion years younger. And it's the ones which are 1 billion years older are the ones that are interesting, because if the process of life played out the same...
For linear.
Yeah, played out the same way there as it is here, that means that the intelligent life on that planet has got a 1 billion year head start on us.
Yeah. And
so they could have become extinct.
But to go...
We're the only living...
Yeah, that's another thing.
Now.
But the thing with the Fermi paradox, and you talk about the fact that if there was something that was intelligent life, they wanted to get off the planet, colonize another place 10 million years. Again, I go back to the thought of like, there's been a zillion. So, if we're talking about life, we have, as far as we know, because we're the only planet that we know of life, we know that there's been a zillion species.
Yep.
And only 1 in a zillion have ever thought about colonizing another planet.
Yep.
So there could be a zillion planets with a zillion species on each planet, but we're just the 1 in a zillion that actually have thought about colonizing another planet. So you know what I mean? So
intelligent life could be rare, right?
Yeah.
Truly intelligent life could be rare. And I think that's what it's pointing towards. Intelligent life is rare. I actually think that means that complex life is rare.
Discovery Roger, go for deploy.